guys, you are back again on the H2O Spirit channel. Today we are going to take the second phase of the chemistry questions that we did last week. Okay, as you can see on the board, we have question number 7. Just like I'll be telling you, and I'll keep telling you, these are questions you shouldn't play with because they are sure to come out in your JAMB 2024. On the board we have JAMB Mock Chemistry question 2024. If you haven't watched our previous video where we talked about question 1 to question 6, please make sure you do that, because today we are going to continue from where we stopped, and in our next videos we are going to continue from where we are going to stop today. So if today is your first time for coming across this YouTube channel, please do not forget to subscribe and also to like our videos. Thank you very much. Now let us go into what we have for today. The question number 7 says what? A gas has a volume of 25 cm³ at XTP. Remember that XTP means standard temperature and pressure. Okay? A gas has a volume of 25 cm³ at STP. Calculate the pressure exerted by the gas if the volume increases by 15%. Now let us go into this interesting question. This question is from a topic in chemistry called kinetic theory of matter and gas laws. So to be precise, this is one of the gas laws in chemistry among the 9 laws. Which law particularly is this? This law is referring to Boyle's law. Don't forget, Boyle's law states that the volume of a fixed mass of a gas is inversely proportional to its pressure, as long as your temperature remains constant. Now, according to the question, a gas has a volume of 25 cm³. So we can say that our V1 is 25 cm³ at STP. Remember that at standard temperature and pressure, our pressure is 760 mm of mercury. Our temperature is 273 Kelvin. Remember, this is standard in gas laws, that at standard temperature and pressure, this becomes your pressure value. Okay? Now, for other units of pressure, we can say it is equals to 180 M. But if you look at the options on the board, you will find out that the options are given in millimeter of mercury. So we are going to work with this particular value. So it will be right for us to say that our P1, which is the first pressure, is 760 millimeter of mercury. Now let's continue. Calculate the pressure, that means we are looking for P2. Calculate the pressure if the volume increases by 15%. Now, if the volume increases by 50%, it means that we are going to first of all get the value of 15% from your 25 cm³. So let's get the increased value first. Our increased value, since we want to calculate for 15% from 25, we have 15 over 100 in percentage times 25, and that will give us 0.15 times 25. So if we multiply 0.15 by 25, we are going to get 0.15 times 25. What we have here is 0.15 times 25, and that will give us 3.75 cm³. This is to say that the volume has increased by this particular value, which is 3.75 cm³. So what will now become our V2? Remember, V1 is 25 cm³, and the pressure increased by 15%. So we have to take 15% of 25 by doing 15 over 100 times 25, and that gave us this. Now if we have this, it means that our V2 will give us what now? 25, which was the initial volume, plus the increased value, which is plus 3.75. And if you add this together, you are going to get 28.75 cm3. Wow, this is interesting. So if you cannot calculate for the value 15% of 25, it means that you cannot solve this problem. So you must know that if you are looking for 15%, it is 15 over 100 times this. If you are looking for 30%, it is 30 over 100 times this. If you are looking for 12%, it is 12 over 100 times this. Okay, now let's quickly bring our formula. Remember that in Boyle's law, our temperature is constant. And if our temperature is constant, it means that we have V1 P1 equals to V2 P2. That's the formula, mathematical relationship in Boyle's law. So what is our initial volume? Our initial volume is 25 times our initial pressure is 760 equals to our final volume V2 is 28.75 times P2. Remember, you are looking for the second pressure. So what you do is that you divide both sides by 28.75 and you do the same here, 28.75. So our P2, which is the second pressure we are told to calculate, will be 25 times 760 divided by 28.75. And that will give us 660.86. 660.86. And I guess that's approximately equal to, because if you look at the options, they are all given to you in whole number, and that will give us 661 millimeter of mercury. So let us go to the option and see our answer. Okay, our answer is not A because you have 25. Our answer is not B. Our answer is C. Now that is interesting. Remember, in Boyle's law, your temperature remains constant. So if I may paraphrase this question, it means that we are to calculate for the pressure exerted by the gas if the volume increased by 15% at constant temperature. So at constant temperature, this condition is imposed on the gas law, and that will give you your answer, 661 millimeter mercury. That's so interesting. Let's take question number 8. The bond found in H3O plus. The bond found in H3O plus is what? This is a very interesting question also. H3O plus is called hydrozonium ion. Yeah, H3O plus is hydrozonium ion. It is formed when an acid dissolves in water. Don't forget, an acid is a substance which produces hydrogen ion or hydrozonium ion as the only positive ion in aqueous solution. So the bond found here is a combination of two important bonds. Remember, if you have hydrogen ion combining with H2O, that is when you have H3O plus. So interesting. Remember, there is a covalent bond here. There is a covalent bond here. The bond formed between hydrogen and oxygen, okay? Now, if there's a covalent bond here, by the time your water combines with your hydrogen, it looks like one of the atom is losing electron for two of them to share. And remember that the bond that will be here, since you have covalent bond, the bond that is formed when there's an unequal share of electron between two participating atoms is called your coordinate covalent bond or your dative bond. So there is a dative bond here. So very interesting. The bond found in the water is covalent bond, but the bond that is formed between your water and hydrogen is what? Dative covalent bond. Other examples of molecule that contains dative covalent bond is your ammonium ion, and those your complex ions like in copper 2 tetraamine and in iron 2 hexacyanoferrate. Okay, so let us go to the board and see our answer. Remember, the bond found in hydrozonium ion is covalent bond and dative bond. Dative bond is also called coordinate what? Covalent. So let us see our options. It is not ionic, it is not covalent bond, it is covalent and dative bond. So the answer to this question is what? C. Okay, we are going to take all the questions from here. Let's take other questions, please. Question number 9. Which of these alkanes exists as a liquid at room temperature? Which of these alkanes exist as a liquid at room temperature? Okay, very, very easy. Remember that alkane is a parent hydrocarbon that has a single bond and that it is a saturated compound. And also, alkane have a general molecular formula of CnH2n plus 2. Now, if the first member of alkane, which is methane, that has one carbon atom, to the fourth member of alkane that has 4 carbon atoms, this one is called methane. That's the first member of the alkane homologous series. Okay, this one is called butane. That's the fourth member of the alkane homologous series. From the first member to the fourth members are gases at room temperature. So methane is a gas, ethane is a gas, propane is a gas, and butane is also a gas. The first member that is a liquid at room temperature is your pentane, which is C5H12. Okay, it continues down to your diesel, which has up to 18 carbon atoms. From there you can have your asphalt and bitumen, which are solid at room temperature. You say, which of these alkanes exists as a liquid at room temperature? Remember, I told you that the first member of alkane is a gas, which is methane, so that cannot be the answer. The second member of alkane is also a gas and is called the lightest fuel, ethane. That cannot be the answer. The third member of alkane is called propane, which is cooking gas, and that cannot be the answer, though it's not in the option. The fourth member is called butane. That cannot be the answer because it is a gas. So this one is a gas, this one is a gas, this one is a gas. The first member that is a liquid at room temperature is your pentane that has 5 carbon atoms, which make our answer to be worth A. Stay with me on this channel. The molecule eliminated in condensation polymerization is what? Remember, polymerization is the process by which 2 or more monomers are referred to simple organic molecule, combines together. Monomers plus monomers will give us a what? A polymer. So polymerization is a process by which 2 or more monomers combine together to form a giant molecule called the polymer. So monomers plus monomer will give us what? Polymer. And this is what we call polymerization. Now this polymerization, they are of 2 types. One is called addition polymerization. The other one is called condensation polymerization. In addition polymerization, there is no elimination of any molecule. For instance, 18 plus 18 plus 18 plus 18 plus many numbers of 18 will give us polythene. Okay, but in condensational polymerization, there is an elimination of either H2O, which is water, or ammonia. So the molecules that are eliminated in condensational polymerization is water and ammonia. Okay, take note of that, please. So the answer is not A, the answer is not B, the answer is word C. If there was ammonia in the option in the absence of water, that would have been the answer. So let's take other questions, please. Question number 11. If a spoon is to be electroplated with gold, the gold should be made the words. Okay, now this is one of the applications of electrolysis. which is used for the what? Electroplating of what? Metals. Okay, now what you have to do for me is this: get your book and your pen. Please jot this for me. Just jot this: rules for electroplating. We are going to summarize it quickly. What are the rules for electroplating? Number one rules: the material to be electroplated should be made the cathode. Please take note. The material, write it down please. The rules for electroplating. The materials to be electroplated should be made the cathode. Okay. Number two rule for electroplating: the material to be used for the process should be made the anode. I want you to know that, don't forget that the anode is more reactive than the cathode. And because the anode is more reactive than the cathode, it is the anode that dissolves in the electrolyte first. And if the anode dissolves in the electrolyte, the anode itself, the metal that makes up the anode, will migrate itself and become deposited at the cathode. So if I want to electroplate a material, what I'm using for the electroplating should be made the anode so that it can migrate to cover the material. For instance, if I have a rod here, this rod, for instance, let's say it is the anode, and the material to be electroplated, let's take this for a spoon, please. Let's take this for a spoon. If this is the anode and this anode is made up of gold or silver, okay, if it is gold or silver, the anode is going to dissolve in the electrolyte, and by the time this anode dissolves in the electrolyte, it will migrate to where the spoon is, which is the cathode. Now, when this gold migrates to where the spoon is, it will become deposited around the spoon in this order. By so doing, you have electroplated this spoon with a what? A gold. If you want this spoon to be electroplated with silver, make the silver the anode so that it can migrate to where the spoon is. So this is the basic law for electroplating, that the material you want to electroplate should be made the cathode. Then the material to be used for the process should be made the anode, because it is the anode that migrates to the cathode. Okay, you can get this down. Don't forget, in electrolysis, oxidation take place at the anode, while reduction take place at the word cathode. Now, oxidation, don't forget the acronym that says oil and rig. Oil means oxidation is loss. So oxidation will lose to the word cathode. Then rig means reduction is gain. So it means that the cathode will always gain, while the anode will always lose. So you make the material to be used for electroplating as the word anode. Please write this important note. Number 3, the electrolytes must be a source of the material to be used. That is to say, if I'm to electroplate with gold, the gold will make the anode. The electrolyte must be a gold salt, e.g. gold chloride, while the material to be electroplated will make the cathode, because it is the anode that migrates to the cathode. So the question says that if a spoon is to be electroplated with gold, don't forget, the gold will have to leave where it is and migrate to where the spoon is. So this spoon should be made the cathode, while the gold should be made the anode. And finally, the electrolyte must be made up of gold so that they can work together to electroplate the spoon. So let's just look at the option. Should the gold be made the cathode? No, totally wrong. Should the gold be made the anode? Yes, correct. The other options are irrelevant, okay? Please make sure you get your writing materials and jot these important notes down. They are very important. Now let's take the other question. The metal that will react with HNO3, the metal that will react with HNO3 to liberate hydrogen gas is what? Now, if a metal is to react with an acid, the metal must be more reactive than hydrogen, because the reaction occurring here is a displacement reaction. So if I have a metal X and is reacting with an acid, in order for this metal to be able to liberate this hydrogen, the metal must be more electropositive than the hydrogen, so that at the end of the day, you are going to get XNO3, as the case may be, plus hydrogen gas. Okay, that's what we are going to get. That's what we are going to get. So the metal must be more electropositive than hydrogen. And remember your electrochemical series, where you were told that Kate never can marry allergy Zeno for sin-legged hydrogen commit Mercury, silver, gold. Wow, that's interesting. Learn this acronym. Now, if you watch very well, you will find out that all these metals are more electropositive than hydrogen, for which they will all displace hydrogen from mineral acid. But if you check the option very well, you will find out that copper is far below hydrogen, so it cannot displace. Check out for silver, is below hydrogen, cannot displace. The only two options we have here is magnesium and iron. But if you watch very well, you will find that magnesium is more electropositive than iron. So magnesium will be a better element to be used for this experiment. So our answer is word C. Okay, we'll take 3 other questions before we... What color is seen when methyl orange is added to a base? What color is seen when methyl orange is added to a base? I'm going to answer question number 13, and I'm going to leave the other JAMB MOCK questions for you to answer. Then you send your answer for me in your comment section. What is the temperature of a gas initially at 17 degrees Celsius and 12 atm if the pressure is increased to 36 atm? You answer this, also answer this. I know this is going to stress you a lot. Diamine and dicarboxylic acid polymerize to give words. Please send your answers to me in the comment section with reasons. Now, let's answer this particular question. What color is seen when methyl orange is added to a base? Remember, this is a titration experiment question, and it's quite very tricky. You have to pay attention to this detail that I'm about to give to you. Remember, if I have a litmus paper, if you put a litmus paper on an acid, remember the color will give you red. Take note of that. If you put a litmus paper to a base, the color will give you blue. So base turn red most part to blue, while acid turn blue to red. If it is a neutral solution, the effect of litmus paper will be purple. Take note of that. Okay. Now, what will be the color of methyl orange? Methyl orange. When a methyl orange is added to an acid, you either get a red color or a pink color, depending on the concentration of the acid. If it is added to a base, you are going to get a yellow color. Take note of that. If methyl orange is added to a neutral solution, you are going to get an orange color. Take note of these details, please. Get your book and your pen. Make sure you are writing them down. Then the last one, phenolphthalein. Phenolphthalein acidic medium will give us colorless. It is a colorless solution. Phenolphthalein in a base will give us a pink color or a red, depending on the concentration of the base. And finally, phenolphthalein in a neutral medium will also give us colorless. So please be attentive to details. Now let me give you this tricky question. What will be the color of phenolphthalein in a solution where the pH is equals to 2.5? That's an assignment for you. Add it to these other questions and send your answers to me in your comment section. Okay, now what is the color seen when methyl orange is added to a base? Okay, is the answer red? No. Check your table. Is the answer pink? No. Is the answer orange? No. The answer is what? Yellow. So when methyl orange is added to a base, you have a yellow color. Thank you very much for staying with me to the end of this video. And this is what we have for you for today. If today is your first time for coming across the H2O Spirit channel, in this channel you are going to be learning mathematics, physics and chemistry. So we have a lot to offer you your forthcoming examination. If you are a student preparing for WAEC and JAMB, subscribe to this channel for more details. Thank you very much. I will see you in our next video.